In Alabama agriculture, effective irrigation depends on making timely decisions throughout the growing season. Several factors determine when irrigation is needed and how much water should be applied. Today we're examining the irrigation scheduling of a cornfield near Society Hill, Alabama, in Macon County. This field was planted with decarb 6835 on April 14, 2026, and the crop is currently in the V9 growth stage. One important factor to take into consideration when deciding when to irrigate is the amount of water a soil can hold. Available water holding capacity, AWHC, represents the quantity of water the soil is able to store and make available to the crop. Corn plants growing on the Marvin sandy loam soil can use up 0.15 inches of water for every inch of soil. At the V9 growth stage, corn water uses an average of 0.15 to 0.20 inches per day. During the week of May 25 through June 1, daily high temperatures ranged from approximately 82 degrees Fahrenheit to 88 degrees Fahrenheit, while low temperatures maintained in the 70 degrees Fahrenheit. Rainfall occurred on several days throughout the week, with the field receiving a total of 6.16 inches. This AquaSpy soil moisture graph shows how available moisture changed over the last 7 days, from May 25 to June 1. The blue line at 100% represents field capacity. The green zone shows the optimal soil moisture range for corn growth, and the orange line at 0% represents the permanent wilting point. At the beginning of the period, available soil moisture was around 50%. After continuous rainfall events during the week, moisture increased, reaching 70%. From May 26 to May 30, soil moisture remained relatively stable, showing that the crop was using less water due to the cloudy days. Another useful feature of the AquaSpy platform is the ability to monitor moisture conditions throughout the soil profile at multiple depths. In this graph, we can observe soil moisture measurements from the 4, 8, 12, 16 and 20-inch layers, each represented by a different color. Monitoring these individual depths helps us understand how rainfall and crop water use affect different portions of the root zone. Following a rainfall event, moisture levels increased throughout the profile. For example, the 16-inch depth increased from approximately 51% to nearly 55% on May 30, indicating that rainfall effectively recharged the active root zone. Similar increases were observed at the 4, 8, and 12-inch depths, while the 20-inch layer showed a smaller response, suggesting that most of the water remained within the upper depths of the profile. The moisture patterns across all monitored depths suggest that rainfall successfully replenished the root zone. However, looking at the layers on the AquaSpy graph, the top 20 inches were replenished on May 30. We will continue monitoring field conditions throughout the growing season and provide updates on irrigation scheduling and crop water management. For additional information or questions regarding irrigation scheduling, please contact Dr. Brenda Ortiz with Auburn University and the Alabama Cooperative Extension System.